Locate all the instantaneous centers of the slider crank mechanism as shown in this figure, right? So this is a slider crank mechanism, and you know this is a crank, sorry, slider, and here we have the crank, right? The length of crank OB is given, and connecting rod AB are 100 and 400 millimeter respectively, right? So the crank is 100 millimeter. So crank means that is going to definitely make a rotary motion, right? So this is going to move like this, all right? And since this is given as slider, this is going to make a movement like this. And here we have the connecting rod that will connect this slider and crank. Connecting rod AB are 100 millimeter and 400 millimeter respectively. If the crank rotates clockwise, right? So this crank is rotating clockwise with an angular velocity of 10 rad per second, right? 10 rad per second. Find the velocity of the slider A, right? Velocity of the slider A and the angular velocity of the connecting rod. So here the slider is going to move only in this direction. So we don't need to worry about the direction because it is going to move only in this direction. So only finding the velocity of the crank rod would be fine, and the angular velocity of the connecting rod AB, right? So we'll start. So what are the data given for us? The crank, the length, the angular velocity of that. So we need to start from there. So omega OB will go with omega angular velocity of OB, right? This crank, that is 10 rad per second. Okay, and OB, the length is given 100 millimeter, right? 100 millimeter, that is 0.1 meter. So based on these two data, I can find the velocity, linear velocity of the crank OB, right? Angular velocity is given 10 rad per second, length is given 100 millimeter. So based on this data, I can find the linear velocity of the crank OB. So 10 rad per second into 0.1, right? So 10 into 0.1, that is 1 meter per second, right? You know V is equal to omega into distance, right? Omega into this distance. So that will give you as 1 meter per second, right? So now we have found the linear velocity of the point B, right? Now the question asked to us is velocity of A and angular velocity of AB, right? So to find that, now we have found the linear velocity of B. From here, we need to move further, right? We'll see how to do that. So first of all, we need to mark all the instantaneous centers, right? So here's the diagram. So here's the crank, connecting rod, slider, and fixed link, right? And fixed link. So we'll first mark the fixed instantaneous centers. This is a fixed instantaneous center, right? This crank is fixed to this. So I1, 2. And this crank and this connecting rod, they make an instantaneous center connection, that is I2, 3. This is permanent type. And this connecting rod and the slider, they are making a connection, but that is one is sliding motion and the other one is rotating motion. So that is I3, 4, right? This is also permanent. And now we have the link, this fixed link and the slider, right? This slider is moving in a path, right? This fixed path. So the instantaneous center between this path and this slider. So I told you, if there's a sliding motion on a straight surface, then the instantaneous center will lie at the infinity, right? Then the instantaneous center will lie at the infinity. So that is I1, 4. So if I consider the fixed link as 1, crank as 2, connecting rod as 3, and slider as 4, the fixed link and crank, that is I12, right? That's a fixed type. Then crank and connecting rod, that is I23, that is permanent type. The connecting rod and the slider, that is I34, that's again permanent type. Then slider and this fixed path, that is I14, that will lie at the infinity, right? So this is a 4-bar mechanism. Why we have 4 links? Link 1, link 2, link 3, and link 4. So 4 links mean, you know, based on the formula n into n minus 1 by 2, n is 4, n minus 1 is 3, 4 into 3, 12, by 2, 6. We must have 6 instantaneous centers. Now I have marked 1, 2, 3, and 4 instantaneous centers. We need to mark 2 more, right? We need to mark 2 more. So we'll produce these lines. So I will produce the connecting rod line and this crank line, right? So when you produce this connecting rod line, that will meet the instantaneous center at this point I34. Right, similar way, I will produce this crank to meet this instantaneous center, and that will make a point I13, right? So I've already told you, based on the Kennedy's theorem also we can find, right? So join 1 to 3. So first you need to draw a circle, then you need to mark 4 points, 1, 2, 3, 4. Then you need to join those 4 points, right? So 1 to 2, 2 to 3, 3 to 4, and 4 to 3, 4 to 1, right? So these 4 points are marked already. Now you need to mark 1 and 3 and 2 and 4 with the dotted line, right? Then we need to go for the adjacent triangles, right? So here 1, 2, 3, right? 1, 2, 3 triangle, and 1, 3, 4. These 2 triangles, the side 1, 3 is common side, right? Side 1, 3 is common side. So I will look for 1, 2, 3 and 3, 4, 1, right? So join 1, 3 to form 2 triangles, 1, 2, 3 and 3, 4, 1, right? 1, 2, 3 and 3, 4, 1 in the circle diagram. The side 1, 3, so this is the side which is the common side. Common to both triangles is responsible for the completion of 2 triangles, right? This slide, this 3, 1 is the side responsible for the completion of this triangle and this triangle, right? Therefore, the center I13 will lie on the intersection of I12, I23, right? I12, I23, right? We are talking about this one, right? So in the diagram, we will search for that I12, I23, right? So I need to produce this link. So when I produce it, it is going there. Intersection of I12, I23 and I14, I34, right? I14, 34, right? Based on these 2, we are going to produce the other one also. So that is I14, I34. We look for that. I34 is there, right? I14 is here. So I will produce this one as well, right? So the point where these 2 are meeting is the I13, the intersection, right? That's the instantaneous center. Thus, center I13 is located, right? So this is the instantaneous center I13 which is located. Join 1 to 3 by a dotted line and mark number 5 on it. So this is 5th instantaneous center. We know we should have 6 instantaneous centers. We'll go for next one. Join 2 and 4 by dotted line, right? 2 and 4. We have to join it by dotted line. So if I join 2 and 4, one triangle would be 2, 3, 4, and the other triangle would be 1, 2, 4, right? And the 2, 4 is going to be the common side for making these 2 triangles. So based on this common side, we will go for link I23 and I34, and we will produce it if necessary, right? So I look for I23. We have to have I23. Okay, I23 is here. then I34, right? I34 is here, right? So I will produce this line, okay? I will produce this line. Then the next one, I12 and I14, right? I12 and I14 based on this triangle. So I12 I have here, this is I12 and I14, right? I14 is here, right? So I will join these two lines, right? So the point where this line and this line meet is the instantaneous center I24, right? So we'll see. So triangles 2, 3, 4 and 1, 2, 4, right? 2, 3, 4 and 1, 2, 4. The side 2, 4 is a common, right? 2, 4 is the common side. So we will make the adjacent triangles to both the sides of 2, 4. Based on that, we will mark this point. Join 2 and 4 by a dotted line on the circle diagram and mark number 6 on it. So this is going to be the sixth instantaneous center. Thus, all the 6 instantaneous centers are located, right? Now you have located all 6 instantaneous centers. 1, 2, 3, 4, 5 and 6, right? We have all 6 instantaneous centers we have marked, right? So now what I have done, we have marked all the 6 instantaneous centers and we have found the velocity of B, linear velocity and angular velocity of B, right? The question asked is, what's the velocity of A and what's the angular velocity of BA, right? The connecting rod BA, right? So we'll see how to do that. So once we have done all the instantaneous centers, now only thing remaining is measuring and multiplying, that's all, right? So by measurement, we found that I13A is 460 millimeter, right? I13A, this is 460 millimeter, right? And I13B is 560 millimeter, right? I13B, this is 560 millimeter, right? So based on Lami's theorem, the velocity of slider A can be written as VA upon I13A, right? Velocity of A is question, right? Velocity of the A is the question. So velocity of the A, either it can be on this direction or it can be on this direction. Only these two directions it can move, right? So we don't need to worry about the velocity direction. VA upon this length I13A will be equal to VB upon I13B, right? So this is what Lami's theorem says, right? So we know the VB is already found, right? This length and this length we can measure and find, right? So if I know this length, this is we can found I13A, this length also we can find. VB, this is already given, not given, we found it. So now I can find the VA, right? That's a vector, right? So VA is equal to VB into I13A by I13B, right? So VB we have already found, that is 1 meter per second. I13A by measurement we have found it 0.46 meter. I13B, right? I13B based on measurement we have found it as 0.56 meter. Okay, so when I solve this, this will give you 0.82 meter per second, right? So this will give you 0.82 meter per second. So based on this one, velocity of A is 0.82 meter per second. So this is have only a linear motion and this will not have an angular velocity. Why? Because this does not have any angular motion, right? This have only straight line motion. And now next question, the angular velocity of the connecting rod BA, right? Again we will go to the Lami's theorem. Let omega B is the angular velocity of connecting rod AB. So BA upon I13A, right? Similarly like this, BA upon I13A is equal to BB upon I13B, right? BB upon I13B, right? is equal to omega AB. You know, velocity upon length will give you the omega, right? So VB, we know that is 1, and I13B we have measured here. I13B, that is 560 millimeter, that is 0.56 meter. So if you replace VB, we have already found 1, I13B we measured is 0.56 meter, then I will have 1.78 rad per second, right? So the angular velocity of the connecting rod is 1.78 rad per second, right?